As engineers, it's our job to use knowledge and judgment to help the benefit of the mankind. And if we don't use our judgment properly, if we don't do the proper investigations, failures can occur. And one of the failures that did occur was the OaklandBayBridge collapse. It happened October 17, 1989 at 5:04 p.m. An earthquake hit the San Francisco Bay Area. It killed 63 people and injured close to 4,000. And of course, the OaklandBayBridge did collapse. The story of the OaklandBayBridge. It started out as a construction project because people were tired of taking ferries from San Francisco to Oakland and they wanted a better way to travel. So the construction started in July 9, 1933, and it finally finished construction November 12, 1936. The bridge has two different ways. One's eastbound, one's westbound, and each one has 5 lanes, and it spans across the San Francisco Bay of California, and it connects San Francisco to Oakland, and it carries about 270,000 vehicles per day on both of its ways.
Okay, we're going to talk to you a little bit about the earthquake today. The earthquake did occur on October 17th, 1989, about 5:04 p.m. It was registered as a 6.9 or a 7.1 on the Richter scale, according to both scales. It lasted for about 15 seconds. The name is called the Loma Prieta, and that's named after the peak of a mountain in the Santa Cruz Mountains. That was actually in the Loma Prieta, where the peak was, is where the epicenter was, about, I want to say 14 miles down, which is the focal depth of it, which is unusually deep for an earthquake at that time, which is normally 5 to 6 miles down. What was unique is that it happened at the beginning of the 3rd game of the World Series at that time, which ironically was between the San Francisco Giants and the Oakland Athletics, both of which hometowns were greatly affected by the earthquake and suffered a lot of damage. I actually remember watching this game at the beginning of it when the earthquake happened. It was kind of an odd thing. Extensive damage was done as a result of the earthquake. Estimates about $6 to $8 billion in damage. It damaged many of the parts of San Francisco and Oakland, including the Marina District, the historic downtown district, and the Cypress Viaduct, or the Cypress Freeway, however you want to say. 42 people were killed on the Cypress Viaduct, and a lot of that happened as a result of liquefaction. What happened with liquefaction is as the shaking of the hurricane followed by the weight of the building caused the soil that the foundations was sitting on to lose its bearing strength, and in effect it acted like quicksand and caused the structure to collapse along with other structures, as you can see. And then also the Bay Bridge collapsed, which you can see right there. It was just a section of it, and it fell down. Only one person was killed as a result of that, and they ended up driving right off the section. And now we're going to elaborate on that a little more.
All right, you guys, I'm going to go ahead and I'm going to talk about what happened. The Cypress Freeway is the worst structural disaster, killing 42 people. And after this earthquake, transportation in San Francisco took a major hit. And as you can see right here, the destruction across all of the freeways. All right, I'm going to specifically talk about why the OaklandBayBridge, what happened. As everybody knows, there's longitudinal forces that's always acting on the bridge. You know, it's always going to happen. But surprisingly, during this earthquake, the longitudinal forces actually accelerated and increased. So on the eastern part of the bridge, which is this part right here, the eastern part, the trusses that connected to the columns were not going to be able to handle any more acceleration. So as the longitudinal forces kept increasing, the bolts on the trusses on the eastern side actually sheared off, which allowed that section to actually just go ahead and move along with the earthquake. Now, as this section is moving along with the earthquake, the strips, which are these little black lines right here, actually started to pull away from the western side of the trusses. So as the strips are pulling away, it basically all the strips just dislocated from the western side, which allowed basically this section of road right here to just have a trapdoor-like effect, or one side just stayed on, but the other side just collapsed fully. So as you can see, it basically just collapsed into the bottom half. And like my colleague said, only one person died today driving off.
So the short-term quick fix was actually very simple. All they did was they just put the 50-foot deck back into place. It took, like, the earthquake happened in October 18th, and by November 17th, the bridge was back open. But because of this, they realized that this bridge was not suitable for seismic activity. So they decided to take the bottom bridge, and they're currently building a separate bridge that goes along the side of it. As of now, the bottom deck is still in use, but once they complete this, they're not going to use the bottom deck anymore, and they're going to use the side deck right here. And it's designed to withstand an 8.5 magnitude, and they're using load absorbing techniques like shear link beams. However, for the upper deck, they decided that the whole thing needed to be retrofitted. So they replaced all of the rivets with a high-strength steel bolts. They added in new steel plates, new bracing on the underdeck, and they encased the pylons in concrete for extra strength. And they stuck in dampers and isolation materials into those columns to absorb the energy and dynamic loads that come across in the event of an earthquake.
Okay, so in conclusion, why do we all care? Well, our bridge, the Oakland Bay Bridge, was a precursor before the Golden Gate Bridge. So therefore, this was very beneficial for that construction because they benefited off of the different things they found out. Like everybody knows, is California area. It's very windy and it has earthquakes. So therefore, when the Golden Gate Bridge was constructed, they were basically trying to implement new technology with the geotechnically. They did it very badly, poorly rather. They put wood stocks in the foundation instead of steel. So that was replaced. And also one thing I think that would have helped that it not fall was they didn't have any checks. As they said earlier, they constructed the building in 1936. Well, in 1989 it failed, and I don't think anybody even checked to see if they was being able to handle the loads over the years. But like I said earlier, the steel strength of the bridge, it failed. Also, as a result, they were testing bridges for wind pressure so they can stop from oscillation and vibratory forces from earthquakes. And I think a combination of these three things is what's getting the new bridge. So like I said, luckily nobody died. Actually, a couple years prior, I think in 2004, the top layer failed again, and some steel debris actually fell down on the drivers. I think 3 people got caught in the steel pile up, but nobody got killed. Surprisingly, people got injured. So this is a pretty big deal. So hopefully they can get it together. And I think the main thing is that we just have to be cautious as engineers of the societal effect, and we could kill people by being negligent. So thank you. You have any questions?